In the previous video, I talked about composition and compared it to inheritance. I've said that inheritance is a way to reuse functionality and attributes. In contrast, composition is a way to make the combination of classes act like a single coherent object. In that last video, I stopped right after I created the classes for the parts, but I hadn't yet put all the parts together. In this video, I need to assemble the personal computer. Now it's time to run some code and see how I'd use what we have created. Going back to the main class and the main method, I'll start creating some objects. First, I'll create an object of type computer case. Computer case, the case equals new computer case, and the arguments, all literal strings, are 2208 and del. And finally 240 to indicate the power supply watts. Okay, that's my definition for a computer case now. PCs generally can't be put together without a case. So what I'm doing here is creating that case. Next I need to create a monitor. This time I'll say it's an Acer 27-inch beast. Monitor, the monitor equals new monitor, and the arguments 27-inch beast Acer. The size is 27 and the resolution is 2540 by 1440. I've now got a case and a monitor that ultimately are going to be used to create my PC. Of course, I now need a motherboard, and I'll make this an Asus brand. I also need the number of RAM slots, which I'll say is 4, and the number of card slots I'll just say there's 6, and the BIOS, I'll say it's version V2.44. Motherboard, the motherboard equals new motherboard, then the arguments BJ-200 Asus, 4 for the RAM slots, 6 for card slots, and as mentioned, the BIOS version is V2.44. Okay, that's the motherboard created. We now have all the parts and can put together our personal computer. I've created instances of a computer case class, a monitor class, and a motherboard class. It's time to build this and see what I can do with it. The personal computer will have the same manufacturer and model as the computer case, so 2208 is the model, then Dell is the manufacturer, and then I'll pass the other variables to the personal computer. Personal computer, the PC, equals new personal computer with arguments 2208 and Dell. And now our 3 created objects, the case, the monitor, and the motherboard. And you can see that here I've created the PC object by passing those 3 other objects to it, as well as the model and manufacturer. In previous videos with inheritance, I was able to use a method from the base class. But how do I get access to a composite object's methods? In other words, how do I make it do anything? Well, I can do this by telling one of its parts to do something. Let's use the example of drawing something on the monitor. I have the method drawPixel at onMonitor, and to access it, I can get the personal computer's monitor object using the getter method, and then call drawPixel at on that object, so I'll do that. I'll use the PC.getMonitor to call the getMonitor method, followed by .drawPixel at, and I'll pass the X and Y locations, 10 and 10 in this case, and also the colour, red. That's one way of executing functionality by using the getter method from personal computer to get the instance of the monitor class that the personal computer contains. In this code, from that returned object, I am chaining the call to the method drawPixel at, and that's invoking that method for me. Likewise, I could call the method load program on the motherboard, passing it Windows OS, for example, as the program I want to run. Let's do that now. The PC.getMotherboard, parentheses, then .load program, and Windows OS as the argument. I'm doing the same thing here. I'm getting the motherboard object that's been created and that the personal computer has a reference to with the variable motherboard. And I use a getter method to get that reference, then execute a method on that. Lastly, let's involve the press power button method on the computer case. The PC.getComputerCase.press power button. Here, in all 3 cases, I'm ultimately accessing functions in other classes, the case, the motherboard, and the monitor, but I'm accessing them through the PC object. This is what composition is and its difference from inheritance. What I did to call the PC object was I created our case, our monitor, and our motherboard. And in reality, when you're putting a computer together, that's what you'd be doing. You'd buy the computer case, you'd buy the monitor, and you'd buy the motherboard, and you'd then put it together to build the PC. I built this personal computer by passing objects, the parts, to the constructor, which essentially is like assembling the computer. I'll continue on now and look at another scenario whereby I can actually hide the functionality further. In this case, I'm not going to allow the calling program to access those objects the parts directly. I don't want anybody to access the monitor, motherboard or computer case directly. What I'll do first is that I'll go to my personal computer class and I'll comment out all the getter methods. You'll remember this encapsulates these attributes, it hides them from the calling code. And just to go back and show you what happened, I'm now getting an error because those methods no longer exist. I really don't want the main class or any class except the personal computer class to make calls on its parts. So next let's create methods on personal computer, which I'll expose to the calling code. The first one I'll call drawLogo, and I'm going to implement that in a private method, and it might do some fancy graphics, but here I'm obviously not going to write that code yet. Instead I'll just call drawPixel on the monitor attribute of our computer. I'm making this private because the only code I want to draw the computer manufacturer logo is the personal computer itself. Private void drawLogo with no parameters. Monitor.drawPixel parentheses 1250 in yellow for the color. Next, I want to call this method from a method I'll call PowerUp. If you think about a computer, when it starts up, you press the power button and then you see a logo come up on the screen. We want to emulate this in our code. Public void PowerUp. Computer case dot press power button. Draw logo. Here, I've got a public method called PowerUp and a private function called drawLogo. The PowerUp function of the personal computer will draw that logo on the screen as part of starting up the computer. And now, going back to the main class, I'll comment out the 3 lines that aren't compiling. Instead, I'll make a call to the PowerUp method on the personal computer, the PC.PowerUp. And now if I run that, I get the result that the power button was pressed, and then drawing pixel at 1250 in color yellow. From the calling code's perspective, this code in main didn't have to know anything about personal computer's parts to get the PC to do something. Composition is actually creating objects within objects. It's like creating a master object. In this case, the personal computer is managing and looking after all its parts, and it uses composition to achieve that. So the personal computer class is the master object. As a general rule, when you're designing your programs in Java, you probably want to look at composition first. If you do any sort of research on the internet, most of the experts will tell you that as a rule, look at using composition before implementing inheritance. You saw in this example I actually used both. All of my products, the parts that made up the finished product and the finished product itself, were able to inherit a set of attributes, like the manufacturer and model. And the calling code didn't have to know anything about these parts to get personal computer to do something. It was able to tell the personal computer to power up, and the personal computer delegated that work to its parts. The reasons composition is preferred over inheritance. Composition is more flexible, you can add parts in or remove them, and these changes are less likely to have a downstream effect. Composition provides functional reuse outside of the class hierarchy, meaning classes can share attributes and behavior by having similar components instead of inheriting functionality from a parent or base class. Java's inheritance breaks encapsulation because subclasses may need direct access to a parent's state or behavior. I showed you an example of using the protected access modifier in a previous video, and I'll talk about why this breaks encapsulation in an upcoming video. Inheritance is less flexible. Adding a class to or removing a class from a class hierarchy may impact all subclasses from that point. In addition, a new subclass may not need all the functionality or attributes of its parent class, and therefore adding the subclass will muddy the waters, meaning the model no longer represents the reality in the code. Let's see an example of that. Let's say I want to include digital products, such as software products, in my product inventory. Should digital product inherit from product? Here I show the model with digital product, inheriting from my current definition of product. If I do this, this would mean digital product has product's attributes, but this isn't true now. A digital product wouldn't really have width, height and depth, so this model isn't a good representation of what I want to build. It would be better if I didn't have those 3 attributes on product, but instead use composition to include them on certain products, but not all products. Now consider this revised class diagram. I haven't completely removed the class hierarchy, but I've made the base class product less specific or more generic. I've removed the width, height and depth attributes from product and made a new class dimensions with those attributes, and I've added an attribute to motherboard, which is dimensions, which has those attributes. So what do you think? Is this a better model? Well, it's more flexible. This design allows for future enhancements to be made, like the addition of the subclass digital product, without causing problems for existing code that may already be extending product. By placing width, height and depth into a dimension class, I can use composition to apply those attributes to any product, as I did here with motherboard, but I'm not requiring that all subclasses be defined with those attributes. This is just one example of the inflexibility of inheritance compared to a more flexible design with composition. Now that you've seen some examples of composition in action, it's challenge time. I'll see you in the next video for that challenge.